Hi, welcome to Twisted Wave 101. My name's Mike and this is the volume video. Today we're going to discuss ways to increase and decrease volume inside and outside Twisted Wave. There are generally three ways to increase volume, and that is with mic gain, normalization, and amplification. Before we get into those, however, let's talk about ways to read volume in Twisted Wave, and to do that I'm going to open up a file with the program. The first and most obvious way to read and check volume is with the large meter over on the right-hand side of the program, which is read in what is pretty normal for most programs, a dBFS scale, or a digital scale. In digital scales, 0 is the ceiling at which you shouldn't go over, and we read in negative numbers down. So you can see here we have -6, 12, -20, 30, and this goes all the way down to 60, which is great. You can hide this meter by clicking on the dot right to the left of it and pulling the tray back, and again you can show and size the meter as well up to what you see here. When you record, it's perfectly acceptable to record into the green, the yellow, and even into the red, but just be careful not to go over 0. At that point the program basically shaves the top of the waveforms, creating square waves, and ends up distorting the audio. Another way to check your audio is with the two numerical meters on the top and the bottom. The top one corresponds to the meter itself, which is a peak readout.
Plus, and Roland Avis preferred.
And the bottom one is an RMS meter, which shows you an average of volume over a period of time, which can be set in the preferences. RMS is more approximated to what we actually hear as human beings, and we'll go into that in a little bit. Another way, and a meter that I like to look at volume, is with the dB scale on the left of the program, which corresponds directly to what you see in the waveform display. On the right of the program, the meter shows you what you're reading out, but doesn't correspond directly to what's inside. And you can notice that by 0 being at the top, but 0 actually being down here. On the left, however, the waveforms do actually hit a numerical value and give you a readout for what's going on in the audio at this point. And you can see we start at 0, and then down to 1, 2, 3, 4, 5, 6, and down to about 20. And then conversely, on the negative side of the waveform, same thing. And a wave that is pushed up here in the positive end or in the negative end will affect how much you can normalize the wave over the period of time through RMS or peak normalization. You can consider these two sides to be equal. The other way to check volume in this program is to go up to File and to analyze the file itself. By running an analyzation, we get a couple different numerical values on the audio waveform that we have displayed in something that we've selected via the entire audio, which we just did here, or even just a small section. The two things you really want to check out here are peak amplitude, which shows here at -8.88, and which sort of corresponds, if we were to look at this spike here, to about what we see on this end over here. And the average RMS power, which gives us an average volume over a period of time. So those are the three ways to check out volume. Let's go back really quick and talk about mic gain. So there's something that's really good to remember, and that is hardware always supersedes software. So if you can adjust your volume at any point in hardware, that's where you're going to be doing it. I took a picture of some audio interfaces in Google, or actually pulled up a search, and I just wanted to go through to show you where these gain knobs would be on a couple different audio interfaces. Most of these look pretty much the same, as they all do. They have some XLR and TRS inputs in the front here, and some corresponding knobs in the front. The Erderall has 2 up front, and corresponding down to the bottom right and left of those TRS jacks are the volume knobs. This is a Focusrite iTrack. It's got 2 knobs right next to the XLR inputs. The top right, this Mo2 box has an input on the front and also an input on the back, and 2 corresponding knobs up on the front. M-Audio device has them just above on top of the unit. And as we start to go down and look at other pictures, you'll see that there's a lot of similarities between these devices. Here's an M-Box. Connections are on the back, knobs fall up on the front, and correspond with the number of inputs. So those are audio interfaces, and if you do have an analog mic and an audio interface, you're going to want to change it in the hardware world. Sometimes you will be using a USB microphone, as I am here, an Audio-Technica AT2020 USB, and my microphone has no dials or switches on it. So in this case, to change the volume that gets into twisted wave, I need to go into my Mac system preferences. I need to select the sound tab and go into the input, choose my microphone, and this slider becomes the input gain for the program. And if I pull up twisted wave, create a new session, and hit record, flip back over to system preferences, you'll see that indeed this actually does change the volume of what's coming into twisted wave. So this is how you would do this for a USB microphone, one that did not have a volume control on the front of it. And go back to twisted wave and close the program here. When we're talking about mic gain and we're talking about gain staging, it's important to let the gain ride through the devices that you have cleared without extra amplification. What that means is you want to set the gain proper at the first possible stage you can. So if you're on an audio interface, that would be the dial next to your input. If you're running through a mixer and you do have an audio interface as well, you want to set the mixer's fader to unity, which is the 0 point, or at least its gain to the 0 point, so you're passing the signal through without attenuating or boosting it, using just your mic preamp gain to increase or decrease the volume. If you don't have those hardware units, then don't worry about it so much. But you will have multiple amplification stages over a period of time if you start to work with other devices, and it's important to set all of those devices to a clean path so the audio can pass through and doesn't jump up and down based on each stage that you hit of volume amplification. So let's talk about normalization. Normalization is defined in Wikipedia as this, and I've added some stuff to it, so let's go through this really quick. Audio normalization is the application of a constant amount of gain to an audio recording to bring the average or peak amplitude to a target level, the norm that you set. Because the same amount of gain is applied across an entire given range, this is mostly the entire audio file, the signal to noise ratio, which is the sound difference between your voice and the sound of the room, and relative dynamics are completely unchanged. Meaning as you increase the volume of the entire track, so comes up the noise floor and everything else that was recorded with it. Normalization differs from dynamic range compression, or just compression, which applies a varying level of gain over a recording to fit the level within a maximum or minimum range. This is important. Lots of people who talk about normalization think it's compression, and it's not. When we normalize a file, what we're doing is increasing or decreasing the volume of the entire file, irrespective to the dynamics of the file itself. So maybe you have a recording where you're fairly quiet the entire time, however you scream in one section, and if a person were to listen to that, they would assume that most of the recording was pretty quiet. But the program, through normalization and an increase of volume, would respect only the hottest peak or the highest wave sample, and it would move that to the threshold that you set. So let's talk specifically about peak normalization. Peak normalization, which we're going to look at first, works wherein the gain is changed to bring the highest wave sample value, which is the highest recorded value of a sample in your recording, to a user set threshold, and that's some number that you give it, or 0 dBFS, the loudest level allowed in a digital system. Since it only searches for the highest level, it does not account for the apparent loudness of the content, and that's pretty important. So let's take a look at some audio in twisted wave. We can go ahead and analyze this audio just to get some idea of what's going on here. And if we look at this, we'll see that the peak amplitude is at negative 0.95, which sort of corresponds to this negative 1 tick here, just a little above. And our average RMS power is negative 22.80. That's cool. When we RMS a file, peak normalize a file, we'll get into RMS in just a second, what we're doing is we're running through the entire audio file, finding the hottest wave or recorded sample, which happens to probably be this guy right up here. Find a numeric value for that, and then move it to the threshold. What's that threshold? So if I highlight all the audio and I hit the normalize button, I end up with a threshold setting here. I can go all the way up to 0, which is full code, which is something that I never usually do, and I can go in negative numbers down. I usually normalize to negative 1, although standards will tell you that you should be normalizing to negative 3. That's more of a setting for music because they needed the extra dBs to master the file, but in voiceover you're concerned with getting the loudest file to the person on the other end of the email. So negative 1 is perfectly acceptable. And if you've downloaded Audacity, that's the setting that's set in Audacity. So when we normalize to a peak level of volume, what we're doing is going through the entire waveform, finding a number, and we know that this is 0.95, and we're setting that number to whatever threshold we set, here -1. Because this already goes above -1, you're actually going to see a decrease when I hit apply, and there we go, a very, very tiny decrease. Let's take a look at another file that was recorded fairly low. It was a good recording, but they just didn't increase the gain in the preamp when they recorded it before. And so sometimes you'll see recordings that look like this, and it's better for you to send in a louder recording because all things being equal, the human brain prefers louder. So in this case, if we were to take a reading just to check it out with analyzation, we'll see that we get a peak amplitude of -8.88. So when I double click all the audio and I try to normalize it to -1, what it's going to do is go through all of the audio, find the hottest peak, which I have a feeling is this person here, and move that peak all the way up to -1 or whatever I set. And if I hit apply, there it goes. If we take another reading of the audio, we'll see that we are at a peak amplitude of -1, which is exactly what we set. So that is normalization. Again, it's not compression, and that's important. Compression will actually start to push down larger peaks, like this one here, and bring up the quieter sections. Therefore, sort of nominally changing the volume over time and bringing the sections closer together so that you don't have to play with the volume knob so much when things get a little loud or a little quiet. And that's a different processor for a different video. Normalization just increases or decreases volume. And it's perfectly safe for you to normalize all the way up to 0 if you'd like. The one great thing about normalization is that you'll never go above 0. It's physically impossible. 0 is the ceiling which you can't go over, which is great. You'll never peak or overmodulate. When you do make an MP3 from a WAV file, however, after normalization, there are times when some samples will get pushed over the 0 dBFS range if you normalize to 0. So it's very safe to normalize to -1, and if you want to stick with standards, -3. Either are okay. So now that we've talked about normalization and this global process, and really quick, you can hit normalize here with the normalize button, and it also shows up in effects as well as normalize. Same thing. That's peak normalization. Let's go on to talk about RMS. RMS normalization is a way for us to get a numerical value for the entire recording. So we have a couple features here in our normalize plugin, peak and true peak, and you can, for purposes of voiceover, think of these as about the same. Then we get to RMS and finally LUFS. So by taking a reading for this entire audio, as we do with analyze, we can tell that the hottest peak is at -3, and that's because I've normalized this file to -3. Which means if we were to check through the entire file, there's one sample that hits the -3 mark. However, many of the samples might be hitting below that. What's a better way for us to approximate the volume for this track, or the average volume if we were to listen to, let's say, 50 tracks or 60 tracks or 10, and to move all of those tracks close together? Well, if we had lots of tracks that were recorded fairly low but had some spikes of volume in them, and we tried to peak normalize them, the end result would be that they all would play at different volumes. So normalization enters and says, look, let's go through all of the samples in the recording, find out the numbers of those, and then divide them by the number of samples that have been taken, therefore giving us an average of the overall volume of the track. Once we've been given that average number, then we can set that average number to something that we'd like. You'll see this a lot when you start to work with audiobooks for companies like Audible and ACX, where they give you a range of -18 to -23 decibels, RMS. Which means as you go from chapter to chapter to chapter, or even book to book, most files will play in the same volume space, and that's important to them, and important to lots of other people as well. The one thing about RMS normalization that's important, though, is it does not respect the 0 dBFS line at the top of the waveform display, or even the meter, which means if I decide to normalize this file via RMS to something like -10, I'll send peaks over the top and distort.
Plus,
right? So I'm going to undo that. The best way to do that, if you need to increase the volume with RMS to a level that sends your peaks over, is to use a compressor or a limiter first. Bring the peaks down and then increase the overall volume of the track. That's sort of beyond the scope of this video, so we're not going to get into it. but just know that RMS is available in this program for you to increase the volume of your track, or sometimes even decrease the volume of your track. LUFS is a lot like RMS, and it's a way that broadcasters are able to hit target volume levels for averages as well. They work on similar principles, except LUFS is a newer standard of the same practice. So let's look at a definition really quick, because I kind of passed that up here for loudness. LUFS is what we call a loudness measurement, which, like RMS, gives us an average volume level for an entire recording, whether it be 5 minutes or 6 hours. So loudness normalization is based on a measure of volume loudness, wherein the gain is changed to bring the average amplitude, or volume, to a target level. This average can be a simple measurement of average power, such as RMS, and it is indeed a simple measurement, or it can be a measure of human perceived loudness, such as that offered by LUFS. In the voiceover and audiobook world, the industry is not yet using LUFS. However, in broadcast we are. So for the voiceover and audiobook industry, we will stick with RMS for the time being. Depending on the dynamic range of the content and the target level, and dynamic range means the dynamics of loud to soft, loudness normalization can result in peaks that exceed the recording medium's limits, 0 dBFS, and we just saw that in the program. In this case, like I just said, the use of a compressor or limiter is needed to account and protect against possible overmodulation or peaking. Cool. So we've talked about normalization. It's fairly easy. And I'm going to go back to this take here. And if I had recorded this, as we did in a studio at some point, before I send this out to an agent, I would want to normalize this file to -1, making sure to use the peak value. Cool. All right, I'll go ahead and save that file, close it out. Let's talk about Amplify. So Amplify does basically the same thing Normalize does. It increases or decreases volume, but it doesn't respect a first sample recording, which means it doesn't go through the file and check to see where the samples are originally. So if we open up a file in Twisted Wave to take a look at this, we can go into Effects and Amplify. Now at 0, in the middle, we're not doing anything to the file. It's a 1-to-1 pass-through. If we go north of the 0 line, we start to increase the volume of the overall track, or whatever we've selected, by the number of decibels in the readout box. And if we go to the left, or into the negative realm, we're decreasing the volume by just a number of decibels. Whereas normalization will go through, find the hottest peak, and move that peak to the number we set. Amplify just blatantly moves the audio a number of decibels as you request. I am very careful with Amplify because you can blow over all of your peaks. So if I go up a couple decibels here, you'll see that they're all starting to go over the top. So why do I use Amplify? I actually use Amplify to take certain sections of the audio down, or to minimize a breath in an area where I just want to leave it in, but I don't want to show it so much. So we have a file here. I'm going to go ahead and normalize this file to -1 peak. The file didn't move very much because this spike is keeping the rest of the audio from moving. So in this case, this is a good case for Amplify. I'm going to zoom in, and when I do to take this file, I'm going to grab the entire word, not just the spike here, because that would be odd for a big shrink of audio right in the middle of a word. So I'm going to grab the whole thing, go up to Effects, Amplify, and I'll bring this down by, let's say, about 5 or 6 decibels. There we go. And if we take a look by zooming out at the file, you can see we've shrunk the spike down. Best way to check this out is to listen to it.
When you combine soft to the touch.
Sounds good to me. Now, because no spike is going up to -1, I can then go into Normalize, and with -1 already set, apply and bring the average volume of the entire track up. And that's where I use Amplify. There might be a breath in your audio, which I don't have here, in which case you'd maybe like to leave it in because it sounds very normal, but you want to reduce the breath because it was a little large. This is a great place for Amplify. So we go up to Effect, Amplify. When I'm reducing audio, I always work in 3 decibel increment amounts. So -3, 6, 9, 12, 15, 18. Those are points at which the human ear can sort of perceive a difference in change of volume. So I'm going to say that there was a breath here at this point. I might bring it down about 6 decibels, apply, and we could move on. Now, there isn't a breath there, so we're not going to hear anything, but that's a good case use for Amplify. Again, be very careful when you're using this because you can send your audio up and over 0. The last two things that we have that change volume are fade in and fade out. And this isn't a global change over time. This is really just a small amount of audio that you've selected. So let's zoom into the beginning of the audio here and look at fade in. When I select some audio and I go up to my fade in button or fade out on the back end, what it does is it takes a linear line from the hottest sample that you have selected all the way down to 0 and draws a straight line. And that's important. Not a parabolic curve, not an S curve, just a straight linear line. So I'm going to go ahead and show you what that looks like here. And you can see it drew from up top all the way down to the bottom. I like to perform fade-ins, not so aggressively on words like this, but maybe up at the very beginning, just so that we don't start with a click or a pop. And I can go all the way to the end of the audio as well. And I can perform a fade out at the end. And that's it. So when do we use where? Well, when we're auditioning our files or we're sending our files as auditions to people, you're always going to want to normalize your files, again to -1 or -3, depending on what you want to use. And when we are working with audiobooks, we might want to increase the volume of our audiobook chapters using RMS normalization as we go through a mastering process at the end. And then we might want to fade in and fade out our audio at the beginning and the end of each of the file to clean them up. And we might want to use Amplify to reduce breaths or to reduce some of the spikes that we see throughout the audio so that we can normalize the rest of the file up. Again, normalization is not compression. Stay tuned for a future video on compression and limiting. Again, thanks for watching, and we will see you soon.